Hello and welcome to this first lesson on Further Pure Mathematics 1 from the Edexcel International A Level, and we are at Chapter 1, Complex Numbers, and the first part of Chapter 1, an introduction to imaginary and complex numbers. First of all, there are many numbers with which you should already be very familiar. Positive integers like 1, 2, 3, 4 and 5, negative integers, same things, but the negative version. 0, which is a strange number and was late to join the game. Rational numbers, which are any number that can be written as a fraction, things like a half, 2/3, and so on and so on. Irrational numbers, which are numbers which it's not possible to write as a fraction. The ones you're most likely to have met are things like square roots, cube roots, fourth roots, pi, and e. Now, all of the above are called real numbers. Frequently, in A level, you'll be told that something is a real number or is a member of real numbers. If that's the case, all they're saying is it's one of the normal numbers that you're used to for many years. It's also worth remembering the symbols that are frequently used for these numbers. Often again in the textbook they'll just use the symbol for the number and not the word. Z plus is used for the positive integers, Z with a minus for the negative integers. Z with nothing at all would be all of the integers, positive and negative. The rational numbers, the letter Q is used. The irrational numbers, and this is very rare, it's not often that you will see it, but the official letter most commonly used is the letter P. And if you include all of them, the real numbers, the letter R. Now, I've done them in bold type. You'll sometimes see these symbols written in bold type. More frequently, you'll see them as written with an extra line down the Z or an extra line through the Q, and so on and so on. Which brings us to imaginary numbers. The easiest way to understand where they come from is thinking about square roots. The square root of 4 is plus 2 or minus 2. Square root of 1 is plus 1 or minus 1. But what about the square root of minus 1? Frequently you might just see it written that the square root of minus 1 does not exist. Strictly speaking, that's not true. It is true that the square root of minus 1 is not a real number. So it's not one of the normal numbers we've become used to. Is the square root of minus 1? This doesn't answer that question, but it does tell you how to write it down. The square root of minus 1 is normally written as I. But in terms of the question, what is the square root of minus 1? Well, it's the square root of minus 1. I is called an imaginary number, and so is any multiple of I. So 2i, 3i, 6i, minus 2 root 5, they're all imaginary numbers. Any number which has got the form bi something times by I, where that something is a real number. Which brings us to our first set of examples. Given that I is equal to the square root of minus 1, write the following in terms of I. Now you should pause the video at this point, have a go at answering those 4 questions yourself. When you're happy that you've answered them as well as you can do, then restart the video. Okay, hopefully you did what you were supposed to do. First question, the square root of minus 25. The easiest way to think about it is the square root of 25 times by minus 1, which you can split into 2 parts. The square root of 25 is 5, the square root of minus 1 is I, so the square root of minus 25 is 5i. The square root of minus 121, following the same logic, you just got to say the square root of 121 is 11, the minus means you'll have a minus 1, so you have 11i. The square root of minus 11, well, you can't square root minus 11, or at least not as a whole number or as a decimal that has any sort of pattern. Again, split it up and say it's equal to the square root of 11 times by minus 1. Write that in two parts. You can't do anything with the first part, but the second part you can write as I, so the answer is root 11I, and that would be the neatest way of writing down the answer. What about the square root of minus 75? Square root of minus 75, the best thing to do again is to split it up into two parts, the square root of 75 times by minus 1, and then split up 75 into 25 times by 3. Now, 2 bits you can do something with, 1 bit you can't really do anything with. So the square root of 25 is 5, the square root of 3 is the square root of 3, and the square root of minus 1 is I. Joining all of those together, you'll have times by root 3 times by I, or more neatly, you have 5 root 3I. Which brings us to consolidation work on imaginary numbers. If you have the Pearson Edexcel textbook, then at this point you should go to page 3, exercise 1A, and for the moment just try question 1. And when you're ready, have a look at the second video.